It should be between 12 and 16%. And the difference between all the curves should not be higher than 3%. Because if it is higher, then you have this phenomena we have talked about, that you have inconsistent results. Here this is according to Vogler, I say 6%, but I would say 3% is much better, because 6% is actually, in my perception, too dangerous. So LAV values, ISO standardization for offset tells you an exact number for 3 paper types. I have selected here just for you to make it easier. Paper type number 1, it was close, 115 grams per square meters, and the lightness value for magenta is 48. Lightness value for cyan is 55. Lightness value for yellow is 89. You remember this? What was your model with this one? This one is here. This one and this one into red, and blue is A and B, A and B, A and B. What do you need more? It's very precise. You need just a piece of paper and a pencil. And this is also for the for red, green, and so on. And the next point is dot gain in the magenta is 12. It's a slightly different compared to black, and it's done. Measure it. What you can measure, you can control, and you should start during the design phase. I think that was actually a short introduction into some guidelines for designers. They can contribute to smoothen the entire process and to reduce the waste and the trouble we may have later on during the printing press, and that will help us then to be much faster. So communication is required. This is actually the message. Talk to each other, maybe make an invitation, and learn about printing presses. This is, by the way, high sophisticated, one of the latest printing press. So you see that there is not only heavy metal cylinders moving something, paper in, paper out. There is a lot of technology involved, thermodynamic, because such an animal can run today 18,000 sheets per hour. We have a case, this is a Chennai-based ITC, for instance. I think it's also known here in Sri Lanka. One of the leading companies in India, folding box producers, and amongst other things. They recently installed a new repress from Heidelberg. They run it day in and day out with 18,000 sheets per hour. And that because of pneumatics, acoustics, drive technology, you know, all that goes in, but I think this is only technical understanding. Let me see what else we have here. Now this is more for technical people, understanding how important the ink splitting is in printing, because sheet fed offset, I mentioned, is oscillating process because the permanent battle between ink and water, and we call it the proper ink split. And the proper ink split is actually, you know, this is the blanket cylinder in a sheet fed offset press. This is the printing cylinder in a sheet fed offset press. The blanket carries actually the image, and the image comes from another cylinder carrying the offset plates. And then you have the ink in between and the paper here, and then you have the ink split. And in this small portion here lies the entire secret of the success or non-success of sheet fed offset printing. If the split here is wrong, then you don't get contrast. If the split is right, then you get